Okay. So, good evening, everybody. So here uh, today the group what we formed, I feel it is a very strong group because here Assistant Professor Miss Pushpa is there from Amity University, and Dr. Ishwar is there from our DAE hospital, and one more MBBS student also supposed to join, but he may be joining, I don't know. So, and others are my student. They are few are from Jadavpur University and Birla Institute of Technology. So basically these things, why we are thinking we are having a bigger aspect of this, so we should go by a systematic way. So here just this is today, it's a informal, very preliminary discussions, and already some of my students, they are working with PPG signal and trying to generate the ECG signal from the PPG signal by artificial intelligence and a neural network. So today here these things, it will be much more similar compared to that. So it's a single lead ECG we will try to develop. So this work will be the initial phase. We will try to establish the hardware. That means this hardware will be mainly we can classify the hardware broadly in three portion. One is the processing part, and that the microcontroller part. Another is the signal conditioning and the electrodes. It will be 3 electrodes normally, and the communication with the Android device, because we will be seeing these things through Android. So there will be through some Bluetooth device, we will connect the microcontroller, and the graph we will be seeing in the Android device only. We will make the app and we will place that things to the Play Store. So this is the broad segregation of the work. So we will decide, and later on, once the hardware is established, then the qualification, because when it will be coming, we are releasing to market, or professionally it is professionally we are going to use the product. Then we need a lot of one minute please. So this is the thing. When the when the process qualification and all these things are concerned, so much more professional people who are using that system, they should involve. That means in that aspect, I think Dr. Ishwar and that Srivarsan, they will be they can help in a better way, and other the hardware part and the processing part. that the who are the engineers and our students and the madam can take care. So today uh, very broadly we will understand because when we will be working on the ECG signal, we should understand the dynamics of it. So very quickly I will take a glance, because this is a very preliminary thing. uh, so Dr. Ishwar and who are already working, Miss Pushpa also may be knowing all these things, but the students who are newly working, so for them only uh, it is like a refreshment. So normally the cardiac myocytes, um, uh, it if you take a cardiac myocyte, so the inner side is having more negativity, and the outer side of the cardiac myocyte, it is slight positive in nature. Okay, so inner cytoplasm of the cardiac myocyte, it will be potassium ion, and the outer side will be dominated by sodium ion. Now if you take a multimeter and take the voltage across the cell, so you will get a voltage of 90 millivolt, minus 90 millivolt. So this voltage is called the resting potential of the cardiac myocyte. So now the electrical pulse which is generated, that is causing the heartbeat, it is from the SA node. Okay, so it will be generated from the SA node and it will be traveling. We know there is basically 4 anatomical chamber in the heart, but if you talk electrically, it may be lesser than that, 1 or 2 or 3. Like your pulse will be generated from the SA node, then it will come to AV node. There will be a delay. I'll tell why that delay is there. Then it will be traveling through the bundle branch, left and right bundle branch. Then it is Purkinje fiber, and then it will be the depolarization of the ventricle and all. It will be causing. So let us take this is the minus 90 millivolt. Now once the electrical pulse generated and the contractile myocytes receive that, what will happen? Some sodium channel will start to open. It's quite slow process. So what will happen if the sodium channel open? So some sodium ion slowly started to enter inside. So it's a cation, and inside there is a negativity. So if that thing is happening, so slowly the negativity of the cell will start to decrease. That means the potential started to increase slowly. So once it is coming minus 70 millivolt, so this is called the threshold potential. After the threshold potential, this entering, the much more sodium channels start to open, and the entering of the cation inside the cardiac myocyte, it is faster, and very sharply it is increasing the voltage, and it is coming to 0, and further it is going to plus 10 millivolt. Okay, so once it's reaching the plus 10 millivolt, that time the sodium channel will close and potassium channel is opened. Now slowly the potassium will start to go out. If that thing happening, so slowly your cell will, because right now it is 10 millivolt. Okay, so now if the potassium channel opened, so cation is going to started to go out. So the cell voltage, it is positive so far, which is started to reduce, and once it is coming to 0 volt, what will happen? Some calcium channel opened, So that time calcium start to enter. So you know calcium is a cation and the valency of 2. So if the 2 potassium ion going out and 1 calcium ion entered inside, the cell potential is maintained constant for quite some time. So this is called the plateau phase, where the cell will be at 0 potential. And after some time, what will happen? The calcium channel close, but still the potassium channel opened, and very fast the potassium ion started to go out, and again the cell voltage is dropped and coming to minus 90 millivolt. Now, so far in gist, the initially at when the contractile cardiac myocyte is not receiving any electrical pulses from the SA node, it was at resting potential, and once it received that, some sodium channel started to open slowly, sodium ion started to enter inside, and slowly the cell negativity started to decrease, the potential is getting increased. Once it is reaching minus 70 millivolt, it is called the resting potential. Then much more faster way the sodium started to enter, and very fast the cell potential increased, it is coming to 0, and furthermore it is going to 10 millivolt. Once it is happening, then the sodium channel closed, and then the potassium started to go out, which will further causing the decrease of the potential. And once it is coming again to 0, some calcium channel opened, calcium channel started to enter, calcium ion started to enter inside, so it is creating some balance. So it is maintaining the 0 cell potential quite for some time, which is called plateau phase. And after that, the calcium channel totally closed, but still the potassium channel is open, and potassium is start to going outside faster way, and again it is dropping the voltage and bringing it to again to the resting potential, which is minus 90 millivolt. This is only happening repeatedly. So when the cell potential is increasing from the resting potential, this is called, because your cell is not neutral, it's a polarized cell, it is going towards depolarize. So this is called the depolarization. So depolarization is a sodium dependent event, and when it is coming again to this maintaining the plateau phase, it is maintaining the cell potential to 0 volt, which is calcium dependent event. Now when again it is coming to again minus 90 millivolt, it is from the depolarized state, it is coming to again repolarized state. So this is called the repolarization. So here now we are concluding 2-3 things. So if you understand this process, you will be very easily able to read the ECG. In turn, we can make our fuzzy algorithm or the our neural network to diagnose the ECG wave. So that's why I am telling all these things. So first, the depolarization is a sodium dependent event, and as the cell potential is increasing, so it's a positive wave, and basically this depolarization is causing the contraction of the cardiac myocytes. Second is plateau phase. This is maintaining for the cell potential quite for some time with 0 potential, which is a calcium dependent event. Repolarization, which is potassium dependent event. Okay, and here the cell negativity is again reaching, so it's a negative wave, and during repolarization your cardiac myocytes will relax. Okay, so this is the gist of whatever so far we understood. Now in the ECG, if I understand this wave is responsible for depolarization, and it is coming, this depolarization is coming from the ventricle, and there is a abnormality. If I properly logic by understand, then I can tell there is some problem with the electrolyte the electrolyte abnormality in the cardiac myocyte. Like that, our diagnostic and all these things, it will come slowly. So now I am coming simple one basic thing, that is the dynamics. So you can take, this is our heart, okay, so this is your, okay, so normally the superior side of the heart will be keeping the positive electrode, and the inferior side will put the positive electrode. Now few things you remember: if the positive wave is traveling towards positive electrode, it will generate a positive peak. If the negative wave traveling towards a positive electrode, it will create a negative peak. If the negative wave traveling towards the negative electrode, it will cause a positive peak. It's very simple. Now, as I told, the pacemaker of the myocytes is at SA node, which is here. So once the electrical pulse generated from there, what will happen? It will first depolarize the atria. Both the atria will get depolarized. Okay. So atria, this depolarization. So depolarization will happen. It is towards this depolarization. So now you see, depolarization is a positive wave. If you can understand that my previous picture, whatever, it's a positive wave and it is coming towards positive electrode. So you will get a positive peak. Okay. So this is called your P wave. Now here is your AV node. So AV node, basically it will slow down the electrical pulse conduction. Because why? Because before the atrial depolarization completes, if the depolarization completes, if the ventricular depolarization start, then with the blood which is coming from the vena cava and the your pulmonary vein, it cannot come to the ventricle. Before that, if your ventricle started to contract, you will not get there sufficient pumping will be not there. Okay. So what is needed? It should give a pause. The electrical pulse generated from the SA node, this is your SA node, this is the AV node. So the electrical pulse generated from the SA node should need a pause till the total atrial depolarization completes. That's why you will get a AV nodal delay. So you will get a flat here. After that, but now you see, some abnormalities, if you can see, if there is a accessory path is here. So rather than traveling the wave from here, then your ventricular depolarization, if there is some accessory path is there already here, and it is entered to this basal ventricular area, and this ventricle started to contract, so it will be faster way, your systole will start. So this is a symptoms of tachycardia. Okay, there are two syndromes are there already, so that we'll discuss later. So basically the right path is from SA node, it will be generate, it will give a pause, then it will come to the bundle branch. Okay, as we know, the upper part of the bundle branch, it is slightly fiber in nature. So the actual depolarization of the bundle branch will take place at the lower segment of left bundle branch. Then it will be upper segment of the right bundle branch. Now you see, this is the depolarization. So depolarization direction is this. So depolarization is a positive wave and it is going towards the negative electrode. so you will get a negative peak. So this is called Q. After that, this electrical pulse, it is conducted, because this ventricular wall, it is the fastest conducting cardiac myocytes, it will be traveling. And one more thing, this left ventricular wall is thicker, okay, it is thicker compared to the right ventricular wall. So if you see the vector of this, it will be this direction, and this is slightly this left ventricular wall is thinner, so it will be something like this, in this way. And if you get the resultant, it will be like this. But this magnitude of the vector, it is the maximum, because the ventricle is the more, it's containing more cardiac myocytes, contractile myocytes, so you will get a large peak there. So again, depolarization, it's a positive wave, it is going towards the positive electrode, so you will get a big peak, so it is called R wave. Okay, this is the R wave. After that, what will happen once this portion is over? And one thing you remember, this normally the depolarization will happen from endocardium to epicardium, but the repolarization will happen epicardium to endocardium. You remember this. So now we reached the most ventricular area, it is depolarized. Okay, now this area is called the basal ventricular area. Now this depolarization will take place. So again, this depolarization will be this direction. So depolarization is a positive wave, it is going to negative electrode, so you will get a negative peak. So this is called S. Literally telling, after this S, your depolarization of the tissue stops, finish. Now the repolarization will start. So now this is the plateau phase, you will get a pause, this for the plateau phase. Okay, after that, what will happen? The repolarization of the ventricle will start. So as I told, repolarization is taking place from endocardium to epicardium, so it will be this direction. So repolarization wave is a negative wave which is coming towards positive electrode. So this so you will get a, so after this, so we here it is plateau phase. Okay, so after plateau phase, what I told, the repolarization of the ventricle will take place. So repolarization is from the epi to endocardium. So epi to endocardium, so it will be this direction, that means it is towards the negative electrode, so you will get a positive peak. So repolarization wave is a negative wave and it is traveling towards negative electrode, so you will get a positive peak. So this is called the T wave. So basically this segment will repeat again and again. So this is basically the dynamics of the ECG. So if you, so once again I am summarizing out this one. So P wave, here one thing, now where is the repolarization of the atrium? ECG will not able to give the repolarization of the atrium. Why? Because the repolarization of the atrium will taking place when the depolarization of the ventricle is happening, but this magnitude is very high. So it is the depolarization wave of ventricle is suppressing the repolarization of the atrium. This is called masking effect. Now if you understand this dynamics, and if you know the where the what leads are placed, and if you simply you can correlate with this, you can diagnose by seeing the ECG what may be the problem. So further this how to do that, all these things, so many things are there, but ECG will give a very gross health of your heart. So again, in summary, I am telling P wave is responsible for the depolarization of the atrium. After that, there will be AV nodal delay. Then your depolarization of the bundle branch will take place. Then the depolarization of the ventricle. Then the depolarization of the basal ventricular area. Then the plateau phase. And finally, this is the repolarization of ventricle. So this is a very simple concept of ECG. After getting the signal, basically we have to play with this concept. Your all logic and everything, it will be you have to do in that way. Now the leads and the controller, everything of the shelf. So I used to tell all of my students always that there is a perfect bridging is required with the academics and the industry. We should perfectly bridge these two concepts. After doing our engineering, our knowledge should not be limited to that paper, some simulation and all. Some practical output should come. So this is all our target should be that only. So we should, our technology, whatever we learn, that should reach to the common people for the mankind. That is our target. So we should do the perfect trade-off. We should not choose the component so that it is very rare, or making some paper. We should not create something which is not required. Some simple thing itself may cater that. So normally after receiving the signal through the electrode, it is needed to be processed. That part I think Ms. Pushpa will help us to do much more economical way, because there are a lot of instrumentation amplifier available in the market, but it may be costly. Those are the differential amplifiers. So in that, there the selection of common mode rejection is a very, very important thing. So you know, this basically this is a differential amplifier. Okay, if this is a differential amplifier, so take, this is R1, this is R2, this is R2, and this is R1, and this is your differential voltage, say VD, and these are the common mode, this common mode voltage, say you take Vn. So if you see in the 3 lead, in a single lead, there is a 3 lead in the ECG. The negative lead, it will be put in the top, near to your clavicle area, and your positive lead, it will be put just right side of your sternum. So it will, this is the thing, and another it will be put on the right leg. So that right leg will, this is the Vn, and these 2 leads will give you the differential voltage here. Now say the R2 is 10 kilo and your R1 is, a typical example, R1 is 1 kilo. So your differential gain, it is R2 by R1 is 10. So now if your differential voltage which is coming from the lead, say that is 5 millivolt of 1 kilohertz, so you will get a 50 millivolt. But actually you will be not getting that 50 millivolt. With that, lot of noises will be present. Now how to suppress that? So that common mode rejection, say this amplifier having a common mode rejection of 90 dB. Now this noise voltage, say take for typical example, this noise voltage is 2 millivolt of 50 hertz. Normally in our body also you will get 50 hertz coupling. In ECG signal you will get the 50 millihertz, 50 hertz coupling. So now what will happen? So normally if this VD is not present, or you can ground this to terminal, Ideally, for this amplifier, it should come, the voltage should come 0, but practically it will not come 0. Why? Because because it's not an ideal case due to the common mode gain. So what is that common mode gain? So it is in dB. So dB means 20 log 10 base differential gain by common mode gain. So that is equal to your 90. Okay. So now your AD is 10. So AC is, so 90 by 20 মানে হচ্ছে 4.5, 10 to the power 4.5. So 10 to the power 4.5 means it is somewhat like 32,000. It will come something. So your common mode gain, it is, the common mode gain is 10 by 32k. So now if your noise voltage is 2 millivolt, so 2 into 10 divided by 32. 30 means 30, it is 26, around 0.6 microvolt. Now you see, which is actual lead, the noise which is coming at 2 millivolt, which is about to couple with the actual 50 millivolt output, due to this higher common mode rejection ratio, it's come to 0.6 microvolt. So these are the engineering we should do here. So this part, so hope now the segregation means what segregation we should do. So now these things I will keep the choice to the student. So now again in broad way I am classifying the first thing. First thing is microcontroller part, that I will take care. Second part is your Android app development, that I will take care. Third part is the INA, the conditioning, so that Professor Pushpa should take care. And the final thing is to qualification, the qualification criteria, and to find out the repeatability of the things that Dr. Ishwar and Sivarshan should take care. And now the student, because this part is purely on medical field, so we should not interfere here. That part Dr. Ishwar and Sivarshan will take care together. These three part, so I requested Pushpa to include some more student. So I think right now Rohit, Anish, Shreya, Chahat, this only there. So you should Mayank also there. So and when I'll request Pushpa to include some student as early as possible, so they should so they should.
Sir, actually, sorry to interrupt you. Actually, exam is going on, so students are not able to join it because in my university on December the exam will be conducted. So that's why this is a secondary task for them. Their project will be started from the next semester. So right now, that's why students not agree to work right now. And you understand on online teaching, they are not bothering about for the work. So right now I don't have that much student. I'm having a CS student, but CS student don't have a this electronic knowledge.
Okay, no issue. So we will see this. So already 3-4 people we are already there. This why I choose this 3-4 students, because they are very energetic and they are doing the work. Because I have the experience. I have the experience to work with them. They will take the things very seriously.
Okay, sir. So they are from electronic background, these students?
Yeah. So now Rohit, Shreya, and Anish. They are electrical. They are very good in microcontroller, because microcontroller, deep learning, artificial intelligence, because they are doing lot of work with me on that. And Mayank is from instrumentation group, of Jadavpur University. He is quite familiar. He is working with me for system identification. It's a part of control.
Okay.
Chahat already developed the GUI for artificial ventilator, which we are working with SRM Medical College.
Okay.
So this is the thing.
Okay. So I pick one of the students with me.
So that's what I'm telling. Let them decide.
Okay.
Okay. So Dr. Ishwar, you have to go to hospital, correct?
Yes, sir. I have to go to hospital, sir.
Okay, so now you
Yes,
can. So what I am telling, just 5 minutes you can express your opinion and you can leave the meeting.
Yes, sir.
Sorry, sorry.
No, what I am telling, Dr. Ishwar, you can express your opinion and you can quit the meeting and you can go to hospital to join the duty.
Yes, sir. Yes, sir. So the explanation was good, sir, about the basics of ECG.
Okay.
Basically, we are at Baba Atomic Research Center. We have previously devised a ECG machine.
Yeah.
Before 3 years, but it is not into use at present.
Yeah.
I am having that machine with me at present. It is having a VGA port for electrode connection. It is a 12-lead ECG. Can take 3 lead, 6 lead, and 12-lead ECGs.
Yeah.
At present, sir. And we want some updations in that machine, like real-time monitoring of ECG. We want and cloud storage.
Yeah. So that part who done in ECIL.
Yes, sir. And I too. Yes, sir.
So anyway, that
yes,
thing
and I too had some meeting with. Yes, I too had some meeting with ECG distributors in Chennai. I met some people who develop ECGs. I also saw their models, how they are devised those ECG machines.
Okay.
And if possible, if we are, and in our hospital we are even planning for teleconsultation kit. So if we are devising this ECG at a lower cost, using it in our hospital also for real-time monitoring also.
Yeah. So we are basically what our these things it should be very low cost. So it's a very initial phase, and slowly by the cumulative effort by all of us, we can go ahead further and we can modify it for the betterment.
Yes, sir. And I also saw some models with only one lead ECG, which can monitor all the 12 leads, but it is not practically useful because at the time of assessing, taking ECG for a patient, we must need some nursing assistant to connect the 12 ECG lead. That is better.
Yeah. So anyway,
but only single lead, they can be. There can be some short circuit if the patient not able to operate the machine, not able to properly hold the ECG leads, there will be short circuit will not be full. So it is better using conventional 12-lead ECG model to take in a cheaper rate if you are able to.
Definitely. But this is our initial stage. We are first going one by one. So that's why we are proceeding with that.
Yes, sir.
Okay, and you that for the qualification and further the diagnostic things and all
validation
that part we need your help.
Okay, sir. For validation and other repetition of the ECG and monitoring and sample parts, I will take care of.
Yeah, thank you so much. So now it is we are running with the time, so you have to join. So you please today it's a very informal discussion, so you can leave the meeting.
I'll quit the meeting.
Thank you,
We'll
doctor.
have
Thank you so much.
we'll meet in the next meeting.
Yeah, sure. Thank you so much.
Okay, sir. Thank you.
Okay, now Miss Pushpa, you can talk to the student and you can finalize who will be.
Hi, myself Pushpa. So if anybody is interested for the signal processing part, so you can join me. I will totally guide you because I already simulated this part and designed on hardware level also. So it's very easy, not that much tough. So if you are interested, you are most welcome. Please let me know on the WhatsApp if you are interested.
Excuse me, sir.
Bolo, Chahat.
Yes, sir. I got disconnected in between due to some network issues. So, like I attended the meeting till the repolarization part. Could you briefly just give an overview so that I could understand what part I was talking about?
हाँ वो मैं वीडियो में पूरा रिकॉर्ड कर लिया, मैं उसको अपलोड कर देता हूँ थोड़ी देर में. तो एक्चुअली क्या हम लोग अभी क्या डिस्कस कर रहे हैं? So here we are all North Indian, correct? Okay. So अभी हम लोग क्या डिस्कस कर रहे हैं कि ये कितना माने ये वर्क सेग्रीगेशन क्या है. सबसे पहले जो माइक्रो कंट्रोलर पार्ट, सेकेंड इज सिग्नल कंडीशनिंग पार्ट एंड इट इज थर्ड वन इज द एंड्रॉयड पार्ट. So these are the parts. So madam she will be taking care about the signal conditioning. So now madam is asking among yourself who are interested for that signal conditioning part. So our next meeting will be, the next presentation will be by Pushpa only. So she will be presenting about the signal conditioning part.
One more thing I just wanted to discuss, sir. Do we have a budget? We can use the SMT component for the designing, because the SMT component is good for us, but for the cost cutting, I have to check about it.
Yeah, that will be done. But the thing is, right now, because the preliminary testing and all, I need to do with the deep only, because it will be easily available, and the people first what I used to do, I used to first show the student the physical output.
Okay, fine. I will try to show that the simulated part, but for the physical, they have to test it, because I designed that circuit which you have seen in my paper on the breadboard. So that was a breadboard output. You can see it's a very nice. But if we will implement the same thing on the PCB, we are getting a more nice output, because the wire length will be the reduced. So the compact circuit is giving a very nice output. So I tested the same circuit with the DIP IC also, because when I was working in industry, so that same kit they developed ECG signal conditioning kit. So they designed that this via DIP components. So we are getting a very good response by that. But I was thinking if we will use the SMT on that condition, about the noise thing will be very less.
Sure. Actually, madam, I will tell you what is the plan.
Yeah.
Basically, this actually we have one social corporate responsibility.
Okay.
So for that we have to spend some amount.
Okay.
For as a social responsibility by the corporates.
Okay.
But once simple by talking by word or by some paper, they will not agree.
Okay.
So we have to show them some at least some working model kind of things.
Okay.
So that thing, because it will not cost more on IC these things, so that the student, they in their home itself they can complete the testing.
Yeah, that's completely true. So, sir, I just want, because at my campus, I just designed the circuit, simulated. So, if some student will help me on the physical level, they will just buy the floating electrode for that, or either clip electrode.
Madam, here I am telling all all the 4-5 students who are here right now,
Yeah.
They are very laborious, I am telling you.
Okay, fine. So no issue, sir. I will work on that. I will test it and I will finalize the circuit and I will tell them. So they will design the circuit only. I need that particular help. If they are stuck in there, so I will modify the circuit on the simulation level. Because you know,
I think already 1 minute already. Rohit is interested in signal conditioning.
okay, that's really nice.
Manish will do microcontroller part. Shreya also microcontroller part. Then this Android part who will do?
Sir, Android part, Anish and I can do together.
Yes.
Okay.
Anish, I, Shreya,
can do it. Yes.
And
We can do it.
Mayank?
Yes, sir.
Mayank, which part?
Sir, I can do the signal processing part.
Okay, so Rohit and Mayank can do that. So now what I will like to request Pushpa, when you can present?
So today's Tuesday, so more probably this Friday or Saturday I will simulate it. So I will present this particular thing.
Okay, Friday, huh? Friday or Saturday, huh?
Yeah, more probably if you will put on Saturday, it's okay because my off will be on that day. So it will be good for us also.
Okay, चाहत कौन सा पार्ट में पार्टिसिपेट करेगा?
Sir, एक बार मेरे को वीडियो देखनी पड़ेगी मतलब like I didn't see the whole part of it like what exactly it is, but for development I can say like web development I have done, so I can help and handle that. And signal conditioning and microcontroller I will like what exactly आप वीडियो अपलोड करोगे मैं एक बार देखूंगी दोबारा फिर बताऊंगी.
ठीक है, तो this is a very preliminary thing. I think all of you know each other in different group. So what I am telling today, you can finalize and post in the group. The discussion time you need not to the discussion you need not to do in the group. I think all of your number, everybody know each other. So you can discuss, somebody, Anish or Shreya may take the lead and discuss with all people and make the final list and post in the group. Like your FOC, like that way finally we did, like that.
Okay, sir.
So this is the thing, and Miss Pushpa also please post that time and date of your presentation.
Yeah, okay, sir. I will post it.
So accordingly, I will also make a plan. So the first part will go ahead with the signal conditioning will be outing. Then the bill of material, whatever the things is needed in text itself, you can tell them parallelly. I think it need your some. How many op-amp required? 4, na?
No, actually we required 2 TL084 because initially I required 2 buffer amplifier, 3 instrumentation amplifier, not 1 instrumentation, but it will take 3 op-amp, then 2 filters. So it required 2 TL084 IC.
Okay.
Yeah.
Okay, so let all the student, let them decide. Already 90% decided. Only Chahat is remaining. She also told whatever. Let it finalize. So we will be, our next meeting will be Saturday.
Okay, so I will tell you the time.
Okay. Anybody have any question from the student?
Sir, we'll discuss and questions.
Huh?
Sir,
We will see the recording and then tell you later if we have any more questions.
Okay. So now we can terminate the meeting.
Yeah. Yes, sir. We can terminate.
Okay. So once again, thank you everybody. Thank you so much. Thank you, Miss Pushpa, to join with us.
Thanks
so
to
we will, yeah. So we will do a lot in future also. So everybody stay safe, be home. So thank you so much. Bye. Take care.
Thank you, sir.
Thank you.